Okay, guys, this is 7-3, and on this one, we're going to discuss how to add, subtract a radical expression, how to multiply and divide binomial radical expressions. There's things that you've done already. The stuff we did yesterday, I believe, is more challenging than the stuff we did today because this really builds on previous knowledge more than yesterday's. So some of those previous knowledges that you can build on. One is if you were multiplying these two binomials, what's the word you would say to multiply two binomials? There's a word acronym that helps you know how to multiply these two. Starts with an F. There you go. The word FOIL. FOIL helps us know a process to multiply two binomials, where you go first, outer, inner, last. Again, that's first, outer, inner, last. And all that's doing is allowing you to take the 5x to both and the 4 to both on the second binomial. We're not going to spend a lot of time right here on actually doing this FOIL. This is a warm-up. If you could FOIL here, you'll be able to use FOIL in today's lesson. Okay? So remember what FOIL is. All right, let's turn the page. When you go to adding and subtracting radical expressions, you want to understand what a like radical is. So let me talk about previous knowledge. So in previous knowledge, would you know what 5x squared minus 3x squared is? What's 5x squared minus 3x squared? What is it? 2x squared. You would say that these are like terms. These are both x squared, so you can't subtract them. You agree? That is the same way that you can have a like radical. A like radical is a radical that has a common root here. To add or subtract like radicals, you can use the distributive property also. So, an example of a like radical, we could say 4 square roots of 2. Oh, I didn't say root in the radicand has to be the same. So if I have 4 square roots of 2 plus 3 square roots of 2, any guesses what 4 square roots of 2 and 3 square roots of 2 is? It really is. That's right. So square roots of 2 are a thing. It's just like x squareds are a thing. How many square roots of 2 you have, if they are like radicals, that's the root that you're taking, and the radicand on the inside are the exact same, then those are considered like radicals. You can add and subtract them. All right, turn the page. Sometimes in your instructions, it'll say add or subtract if possible. So 4 square roots of 2 minus 5 square roots of 3, could I subtract there? No. No subtracting, it's not possible. They're not like radicals. You follow that? Talk to me, Goose. You follow? Okay. All right, of A, B, and C, all I want you to do on A, B, and C on your paper, if you have your notebook, just circle the ones that can be added or subtracted. I don't want you to even do it yet. Just circle the ones that can be. I'm gonna scan up, circle the ones that can be. And I'll scan down. How many do you think I circled? I did. There's 2 that could be. These can be added to make 5 square roots of 7. These are not the same. They're not the same root. These can be to make 9 square roots of xy. So that's a basic understanding. I think it's not a real hard concept to get, but knowing that will allow you to simplify radical expressions. You good with that so far? So yes, Meherba. And then we can also multiply and divide binomial radical expressions. On the multiplying part, multiply radical expressions that are in the form of binomials using FOIL, like we said before. So let's FOIL this out. Let's see what this example would go to. Somebody tell me what F would give you. 6. Thank you for playing along. Somebody tell me what O would give you. I like that. That's 3 times 4, make 12 square roots of 5. Somebody tell me what I would give you. Very good. And somebody tell me what, now we're going to check your knowledge. What's L going to give you? No. No. Okay, I'll go with what you said, even though it's not complete. I'm fine with this. Better write that down and understand why. Square root of 5. Remember, if you're multiplying square root times the square root, you can multiply the radicand to make square root of 25. What could that be, though? 40. Why is it 40? What's the square root of 25? Times 8 is 40. So when you multiply the like radical thing there, that square root of 5 and square root of 5 just becomes 5 times 8. Okay, so I multiplied the final answer. What do you think the first number would be? 46. Good job. These things can both be combined. They're like. Plus, what do you think the next part is? Very good. That is, if I was to multiply 2 binomial radical expressions, I could expect something like that. Any questions on that one? You're writing it down? There is one cool thing when you're multiplying right here. Sometimes when you're multiplying, you multiply with a thing called conjugates. And they are expressions that it's square root of A plus square root of B and square root of A minus square root of B. So it's kind of like difference of squares. You remember difference of squares where it's the same binomial but with a different sign? What happened in those situations? What would happen if I took x minus 7 times x plus 7? What would I have? What would the whole thing be? This is a difference of squares. Remember these? The difference of squares is the one binomial that comes from 2 binomials. It's the same binomial with different signs. The O and the I do what to one another? Say it one more time. The O and the I do what to one another? They do. They can cancel each other. Now you can predict if you were doing something like this right here, these things called conjugates, the O and the I could potentially cancel one another. So right here, the little rule says the product is the difference of squares. Let's look at an example of that. I've got an example I'll show you. Here is an example. Follow this example in your booklet here. If we said 3 square root of 2 minus 9 times 3 roots of 2 plus 9. Let's do the first. What's 3 roots of 2 times 3 roots of 2? 9 roots of 4 is right, which is what? 18. This square root of 2 times square root of 2 will be 2 times 9. 18. All right, what about the outer? Plus 27 square roots of 2. What's the inner? Negative 27 square roots of 2. So do you see now that we know that we can add and subtract or combine like terms, this 27 square roots of 2 and this negative 27 square roots of 2 are going to eliminate one another, aren't they? And then you have the negative 81 there. And so these things go away, and you end up with negative 81 and a positive 18 for what, a negative 63? So that's what can happen when you multiply conjugates. You get something like that. Make sure you write these things down. I'm not writing for my benefit. And the last thing is rationalizing binomial radical denominators. So in a situation like this, there is a radical sign in that denominator, isn't there? We can't have a radical sign in a denominator. So if I wanted to get, it's not just square root of 5, so I can't just take this thing times the square root of 5. It is in an expression, a binomial expression. So if you think about what we just did right here, how we multiplied this times its conjugate, and it got rid of the radicals and ended up with just a number, didn't it? So let's see if on something like that, what if we go multiply it times 1 what? Yep, and let's do that to the top and bottom. So on bottom, let's focus on the bottom to start. 1 times 1 is what? That's easy. The outer and the inner, that'll be a positive square root of 5 and a negative square root of 5. Those will go away, won't they? And so we end up with minus what? You gotta, all of you in the room got to be able to answer this one thing for this. What is it? 5. Okay, so let's stop. I just said this is very important right here. Everybody in the room's got to be able to answer this question, or this homework is going to be really, really hard for you. The last is negative square root of 5 times, and Matthew, you got it, so you don't have to say it twice here. Negative square root of 5 times a positive square root of 5 is negative 5. Because take it times itself, the radical sign will go away there. So the denominator in this situation is negative 4. You agree? The numerator is what this lesson is also about, multiplying binomial expressions. We can still do this. What's the first going to be? What's the outer and inner going to give us? Outer and inner. Outer, inner, outer, inner. What's the outer going to give you? We'll stay with that. What's the outer going to give you? Three square roots of 5. What's the inner going to give us? No. Anything times 1 is itself. Square root of 5. So you got 3 square roots of 5. Square root of 5. What will they combine to? Yes, very good. 4 square roots of 5. And the last would be what? Square root of 5 times square root of 5 is? There you go. So the numerator would simplify to, we got the 5 here, the 3 here. We would have 8 plus 4 square roots of 5 all over negative 4. You with me on that? Could we simplify here? Yeah, I see 8, 4, 4. So that would simplify to 2 plus square root of 5 all over negative 1. If you're not writing this down, please, I don't know what else to say there. It's the only way to help this stick.